Okay, so today we're doing day 2. Yesterday we were finding the solutions. Today we're going to finish that up. On this first slide, we're going to talk about converting standard to factored form. That's pretty much all we were doing yesterday. So all of that was standard form, and we were writing it all into factored form. So here are the steps to what we did. You don't have to write them down word for word. You can paraphrase them. But here is what we did. So first, we factored by grouping to write as a product of linear factors. So remember, that just means factor. Then, if we couldn't factor, we were given some other information, either a root, a zero, a solution, an x-intercept, a factor, anything like that. So we used synthetic or long division to divide, then kept factoring. So remember, we had some multiple step problems. And then once you have completely factored the expression by doing one of those things, we set each factor to 0 to solve, equal to 0, and solved it for the roots, or whatever else I was being asked for, okay? So can you write this down in your notes? I'll give you a couple minutes. Okay, so I have f of x equals x to the 4th plus 3x cubed minus 13x squared minus 15x. And I'm given that x plus 5 is a factor. So yes, Diego said we should use synthetic. Do you agree with him? Okay. I agree we should use synthetic, but I don't think that's going to be the first step this time. Okay. Yes, really. So let's look at this equation. It has something in it that none of our equations yesterday had. Okay, so I'm going to look at each of the terms. In the first term, do you see how I have x? I have another x, and an x, and an x right here. So what is it called if I can take something out of everything? GCF. So I have to start by factoring, okay? So I do have a GCF. What is my GCF on this problem? An x. So I have f of x equals x times x cubed plus 3x squared minus 13x minus 15, okay? Now, this is where Diego said we use synthetic division. I did take out the GCF, so now I can do synthetic division with what was left, okay? But that x is going to be part of my answer. So if I have x plus 5 as a factor, what number goes into the box when I do synthetic division? Negative 5. Good. And then across the top, I have 1, 3, negative 13, and negative 15. Okay? So I'm going to bring down the 1. This is negative 5. 3 minus 5 is negative 2. Good. So this is 10. Negative is positive 10. Negative 3, positive 15, and a remainder of 0. Is this okay so far? And I know it's just a bunch of steps all on top of each other, but you know how to do all of them. What do I do next?
Bring down the x's. So I have x squared minus 2x minus 3. Do you all know what to do with that one now?
Yeah.
What do I do now?
Bring down the other x.
What other x? Oh, you're talking about right here?
Yeah.
Okay, I like that. Good.
Call it the t-shirt.
Okay, we're going to call it a... Okay, Caesar said we do the t-chart. What does he mean by that? We're going to factor a times c and b. So negative 3 and negative 2. So what multiplies to negative 3 and adds to negative 2? Negative 3 times 1. Okay. Do we all agree with that? Okay, good. I like it. Oh, my stylus is dirty again. So I have x times x squared minus 3x plus 1x minus 3. And then I have a GCF of x times x minus 3 plus 1 times x minus 3, which leaves me with x times x plus 1 times x minus 3. Okay, is that my fully factored equation? No. Okay, I do have to equal parts of it to 0, but let's look back up at the original. What is the degree? What is the name of this graph? What is it called? Up here. Let's look up here again. You see where I'm talking about? Fourth degree, which is quartic. How many factors do I have right now? 3. Is that enough factors? No. So what's my fourth factor? X plus 5 from the beginning. So I have x times x plus 1 times x plus 3
And then this x plus 5
Oh, we got that wrong.
comes from here. And isn't that what I said yesterday? I said that there is a very good chance that at least one person from each of my classes will forget the original. Oh, you know why? It's my fault. I forgot to box the given. Remember, I said box the given, so you remember it's there. Okay. So is that, yes, Danielle? Because I've already divided it all the way out. I want to have a constant term as my last one in synthetic division, so I just hold on to the x until I start writing it in factored form. Yes, question?
Like, after you do the synthetic division, like when you run out the power divided, why is it like x?
Why did it what?
Why is it, after you run out, why is it x to
The-
x cubed or something?
This x squared right here? Because once I took out the GCF, 2 is one less than 3. Yeah, I subtract 1 from each time. Because, Josh, the fourth x is going to be that one right there that I factored out. Okay, those are all good questions. Am I done with this problem? No. I want you to write the roots. So, help me out. What are the roots on here? I have x equals what? 0. What else? -1. -3. Is it -3? No, it's +3. That was my fault. I copied it wrong. I'm sorry. You were right. It's +3. My bad. And -5. Okay, am I right now? 0, -1, 3, and 5, -5? Yes or no?
Yeah.
Sorry, I fixed it. Sorry about my mistake. Now those are that's the full answer, okay? Ready for you to try one? Okay, so the second one is a you try, and so are the last 5. Okay, let's check these. It was not just you. Okay, here's the work. So, between the first and second line, I skipped some steps, the steps where we show our factoring. But if you made your t-chart, what multiplies to 1 and adds to -2 is -1 times -1. So that means my fully factored form is f of x equals x times x minus 1 times x minus 1. Or if you put f of x times x equals x times f of x equals x times x minus 1 quantity squared. If you left it expanded, that's okay. And then at the end, I asked you for x-intercepts. If you're at 0, 0, 1, 0, and 1, 0 again, that's okay. Or you could have written multiplicity too for that, okay?
Yes, ma'am.
Next, we have one more thing to add. So these words, you've already written them. Please don't recopy them. The important part is this last bullet point. This is new. I want you to include it. It says, don't forget to check for a GCF, because that's what we did today. We didn't have that yesterday. Make sure you check for a GCF. It can be a number or a variable. It can be either one of those. So it could be like 4x, or it could just be 4, or it could be x, or anything like that. So check for that before you factor or divide. So this last step is actually going to be the very first thing that you do, just like when we did regular factoring. Always check for the GCF first. Okay, you have 5 you tries. I'm going to give you the rest of the period to work on these. I will show you the answers at the end. You have 13 minutes. Work together. Just do it. Just try it. Okay, here is the first answer. Is that what we got? Yeah? Okay, make sure you got the right intercepts. Are you done with number 2 or still working on it?
I'm done.
You just walked back in the room. Okay, I'll give you about 30 more seconds for number 2, then I'll put that answer up. Okay, here is the answer for number 2. Is that what we got? This one had a GCF. The first one didn't, but number 2 had a GCF. And then we just factored a quadratic normally. And the intercepts then are 0, 0. That was for my original factor, my GCF. -1, 0, and 2, 0. Are you done with number 3 yet? No, is that one taking us longer? Okay. I'll give you another minute. Okay, here's number 3. Check that, please. I just started the recording again.
Wait, I got this.
Here's number 3. Here are the last 2. In case you got that far, please check your answers.